Okay, welcome back to our grade 10 maths lessons. I'm Miss Awinup, your teacher. In our last lesson, we looked at how to draw a parabola or a graph of a quadratic equation using the table of values, okay? Now, in today's lesson, we are going to sketch the parabola, okay? We're not going to use the table of values. It should take us a little less time than when we had to draw up the table, okay? So we're sketching parabolas. Parabola. Okay. So to draw the parabola, there are three main points that we need to find before we actually sketch it on a Cartesian plane, okay? Now those points are, one, we will need the x-intercepts, okay? We will need the y-intercept, and we will also need to find the turning point in order to draw the parabola, okay? Now, let's have a look at an equation. Given this equation, let's work out let's find the x-intercept, the y-intercept, and the turning point, and then we'll see how we plot it on a Cartesian plane and then sketch our parabola, okay? So given the equation, let's see, this is an example. So we have y equal to x squared plus 2x minus 8, okay? X squared plus 2x minus 8. So the first step we need to determine here is finding the x-intercepts. How do we do that? We already know from our previous lessons that wherever the graph cuts the x-intercept, y will be 0, okay? So if y is 0, we need to substitute that y into the equation so that we find x. Okay, so y is equal to 0, we will find x. Let's see how we do this. Equation again, y equal to x squared plus 2x minus 8. Substitute 0 into the equation. We have x squared plus 2x minus 8. Okay, in order to find the x-intercepts, we need to apply the null factor law here. So we have to factorize this equation. All right. Now, all factors of negative 8, which will give us a sum of positive 2. So we have two sets of numbers, negative 4 and positive 2, and negative 2 and positive 4. Now, which of those two factors will give us a sum of positive 2? It's the second lot of factors here. Okay, so y is still 0. Then we write this part of the equation as a product of the binomials, okay? So x plus 4 and x minus 2, okay? This is at the point where we apply the null factor law so that 0 is equal to 1 factor here, x plus 4, okay, or x minus 2, okay. So in order to find x, we need to solve. So we take 4 across, and x is therefore equal to negative 4. And here we take 2 across, negative 2. So x here will be positive 2, okay. Keep in mind y is equal to 0, okay. So if we give the x-intercepts as coordinates, the first x-intercept will lie at the point negative 4, 0, and the second x-coordinate will be on the point 2, 0. Okay, so we found our two x-intercepts. That's the first set of points we need for sketching the parabola. The next thing to do is to find the y-intercept, okay? Now when we are finding the y-intercept, this time x will be equal to 0. Now that's also a fact that we've already learned. Wherever the graph cuts the y-intercept, x will be 0, okay? So substitute that into the equation. Let's see. We are going to find y-intercept. So x is equal to 0. All right. So again, we are using the equation y equal to x squared plus 2x minus 8. All right. And we have x equal to 0. So y is equal to 0 squared plus 2 times 0 minus 8. Okay? 0 squared will give us 0. 2 times 0 will also give us 0. So we have negative 8 remaining. All right? Now that's the y-coordinate of the intercept. To give the point, we need to identify the coordinates. So the coordinates of the y-intercept will be 0, negative 8. Okay? So we have currently our x-intercept and our y-intercept. Now let's see how this will go on a Cartesian plane, okay? Before we do the last part of our working out. Okay. Now let's see. This is a sketch, so sometimes it does not really need to be so accurate. All right? So we have negative 4, which is here. Okay, negative 4. And we have positive 2. Okay, so our first x-intercept will be at this point, and the second one will be at this point. Okay, when y is equal to 0. All right, now what about our y-intercept? Where does it lie? Let's see. 8 is here, so x is 0 and y is negative 8. Okay, so you find your x-intercepts, your y-intercept. We plotted it onto our Cartesian plane. Now we need to find out where the graph will actually turn. Okay, so this is a parabola. There is a turning point before it goes back upward. Okay, so in order to find that turning point, let's see. One thing we must remember is that the x-coordinate of our turning point lies right at the midway of our two x-intercepts. Okay, so we need to find a number that lies at the center of positive 2 and negative 4. So we are going to add our two x-intercepts. Okay, so that's negative 4 plus positive 2 and divide that by 2 because we are trying to find the halfway mark. All right, so let's see. Negative 4 plus positive 2 will give us negative 4. Excuse me, not negative 4, but negative 2. Okay, and that's going to be divided by positive 2. Okay, so our x-coordinate is negative 1. Okay, now we are not going to stop there. We need to find the y value of the turning point. So get negative 1, substitute it into your equation so we can find the coordinates. Okay, so y equal to x squared plus 2x minus 8. All right, y is equal to negative 1 squared plus 2 times negative 1 minus 8. Okay? Now, negative 1 squared is positive 1. Positive 2 times negative 1 will give us negative 2. We have minus 8 here. Okay? So the y value is negative 9. Okay? So, x coordinate is negative 1. Y coordinate is negative 9. So we have to give this as coordinates. So we have negative 1, negative 9. Okay, now let's go to the graph. Cartesian plane, negative 1 is here. Okay, and negative 9 is down here. All right, so that point lies here. Okay, now what do we need to do now? We simply connect all our points here so that we form the parabola. All right, let's see if we can do this nice and neatly. Okay, so we cut the x-axis at positive 2, come down to the y-axis, cut the y-axis at negative 8, okay, and when we hit negative 9, we need to start turning here, and then the graph continues up to the other x-intercept at negative 4. Okay, our graph here does not look too good, but it's a sketch, remember. I mentioned before, it does not need to be as accurate as when you are using the table. Okay, so the equation must be written next to your graph so that we know that this graph is representing this equation. Okay, 2x minus 8, and we give the coordinates of the intercept. Okay, and the y-intercept at 0, negative 8, and the turning point at negative 1, negative 9. Okay, so there is our sketch of the parabola. That's the equation of that graph. Okay, I hope you've learned something here. It's quite interesting. This is the same method you will use for any equation given to you if you are asked to sketch the parabola. Okay, now we're almost at the end of our topic on algebra. We've looked at linear equations and their graphs, and we've looked at quadratic equations and their graphs. Okay, in our next lesson, which will be the last one on algebra, we will look at practical applications of quadratic equations. I hope you will join me then. I'll see you then.